Hello, everybody. Welcome to this SANS Cloud workshop. My name is Simon Vernon. I'm going to take you through our experience this afternoon, or this morning, or this evening, wherever you are in the world. I'm going to talk a little bit about how to secure systems in the cloud, especially after a bit of a lift and shift migration. Before we get started, there's a couple of little hints and tips about how to communicate. As part of this workshop. We have Slack, and we have some SANS staff in their Slack as well who are here to help you out. So if you can't access part of the recordings, or you want to communicate with people, if you can focus most of your communications through Slack, it means that we can engage with you, and we can answer questions, etc. And if any questions come through Slack, I will have it in front of me. I will try and read them off as we go through, and I'll make sure we cover all of the things that get dropped in there. The webinar is recorded, so if you're watching this later on, hello again, good morning, good afternoon, good evening. It might even be the weekend by then, but yeah, very, very big welcome. So my name's Simon Vernon. I am a SANS instructor, as well as actually working for SANS. I am head of R&D, which is the tiniest R&D department in SANS, as in there is just me. And I build ranges. I participate in building some of the NetWars services and what used to be known as the Jupiter Rockets ranges, things for cyber threat, and all of the boot up CTFs. Yeah, that is all me. Today, though, and for the next 2 hours, I'm going to talk about how to harden some basic infrastructure inside Azure, primarily inside Azure, and from a basis of a poor migratory status. So we've got a bit of a platform that's going to be migrated into the cloud, and we're going to look at how we can defend that, what implementations, controls we can put in place in order to gain access to things like visibility. So before we start that, I'm just going to give a bit of an introduction here to the actual workshop itself. So this is the Protecting Cloud Assets and Improving Security workshop with me, Simon Vernon. There is a link at the top of this page. Now, you can't click on it, obviously, but you can write this URL into your browser. It will download you a PDF. This is the walkthrough for all of the steps and things you need to follow through the process in order to harden this infrastructure. And this is yours to take away with you. So you get to keep the document, you get to keep the code that I've written, that actually produces the web application, and you get to keep all the instructions on how to harden it, and some quick tips and tricks on how to analyze the data afterwards as well. So this URL, this workbook URL, is really important. Grab a copy of that. We will post a copy of it into the Slack channel as well. In fact, I will do that right now. And that will download you a PDF of all of the instructions. Now, I am an SANS instructor. I'm instructor for 488, among a couple of other courses as well, but primarily focusing on cloud security. And this workshop is really targeting 388 and 488 level students. So this is the content and the curriculum for those courses. We are essentially extending on that for this workshop. I hope you enjoy it. I'm going to dive straight in before I start talking a little bit more about the application stack, because if you're going to follow along with me and deploy this infrastructure, there are a few things we need to get going first, because it does take a few minutes to roll out. As this is the cloud, everything takes a little bit of time, and it depends. Sometimes Azure is really quick, and other times it can take 30 minutes in order to think it. Oh, the link does not work. Sure, yeah, it definitely does. Yeah, that link definitely does work. It's got a capital W in the actual file name, so make sure you've got that. Make sure you've got that there. What I will also do as well is I will download a copy, and I will put it directly into. I'll put it directly into the folder for you as well. Just grab a copy of that file. And there we go. So we have a copy of the file in there as well. Now, the file is also going to link you through a Git. Now, the Git is where all of the source code is as well. Now, there's source code and all of the content of this web application, everything is for you guys to keep. So you get to keep all of this perpetually. Inside that Git, there is some instructions as well. And some of the prerequisites for this lab are, which are pretty simple. You need a Azure account, which you are the owner of. And I would recommend you don't necessarily use an account that you're already using for something else that's production, because we're going to build something inside it that's quite vulnerable. Before we start hardening the actual application, we need to create something that's pretty poor from a security perspective. So I wouldn't want you to put anything else at risk. So if you've got an Azure account you use for labs, or you're currently doing a SANS course and you've got an Azure account for that, you can use that. That's absolutely fine. Just be aware that we are going to build something pretty vulnerable. But you need an Azure account that you've got control of, and you need shell access to that Azure account utilizing the CLI, and I'll walk through that in a few steps' time. We are going to build out some services. We're going to build out this service. And before we do that, I'm going to give you a bit of an introduction into this environment. So a lot of organizations, when they start their journey into the cloud, will decide upon a basic or a simple system that they want to move first. This becomes a kind of an acid test. They will build some infrastructure. They'll experiment. You decide which services they're going to use before they move something across. Now, my recommendation for that process is always move the security systems first, because traditional on-prem security systems don't always have the capability to handle things in public cloud. So if you build out the security systems in the public cloud first and then port those across, you maintain visibility of your on-prem infrastructure while you're now in hybrid mode, and you can monitor everything that comes in that you push into the public cloud. Now, unfortunately, this is a bit of a hard sell. It doesn't work. And to be honest, out of the 30 or 40 organizations I've communicated with or handled or consulted with in the past 10 years, when it comes to migrating into the public cloud, maybe only 3 or 4 of them have actually heeded this advice and done what I recommended. And inevitably, the outcome is, if you move your security systems first, you maintain visibility, you maintain oversight of your infrastructure, which is the most important thing. So what we are doing in this little workshop is we're going to delve into this realm of some native security services that are available as part of the cloud offerings, and they are numerous. There are so many controls we can put in place. But organizations miss this. They don't implement things properly, and it's a failure of planning, a failure of strategy that do it. What happens is we get the case of lift and shift. Lift and shift is a nightmare for us from a security perspective, because it means that rather than utilizing the very capable platforms that the cloud providers are offering, we are essentially treating it in the same way as we treat on-prem or an extension to on-prem. That's just not an efficient or an effective way of utilizing the public cloud. So the entire process we're going to go through is we're going to deploy and build out an application. Now, I needed a bit of a narrative for this. I like some storylines to keep things a little bit real. So I created an airline called Fairline. Fairline is going through the standard cloud migration process. They've ignored all the advice from the security practitioners that they've spoken to. They've decided to go down the route of lift and shift, and they've moved one of their web applications into the cloud. And now they have contracted you as their cloud security consultant because they're being attacked and they can't really see what's happening. So they think their security is okay. This is another common scenario. I actually was with a company literally 6 weeks ago, doing some very just sort of open consultation with them, giving them a little bit of advice. And they decided that no, they weren't going to rewrite their application. They were just going to lift it, put it into the cloud, press play, and off they go. And they contacted me literally 2 days ago, just as I was coming back from my holidays. And they said the first thing was, this is costing us a fortune. We didn't think the cloud was this expensive. And my response to this was, you haven't even turned on any of the security systems yet. What did you think was going to happen? The failure to plan is really bad, and they think that the security is okay without knowing. How common is lift and shift from on-prem to the cloud? It's frighteningly common. I mean, it's terrifying. There are so many organizations who do this blind, without taking advice, without talking to consultants. It is very, very common. The worst one I had, and I mentioned this during my during classes in 488 as well, was during the beginning of COVID. A organization contacted me and asked me if I would become an incident handler breach for them. And when I got into the details of it, what they had done was actually moved an Exchange server into Azure. They hadn't adopted Microsoft 365 Exchange services. No. They actually moved their on-prem Exchange server and put it in Azure, which is terrifying and a nightmare. And it also got hit. It got breached almost immediately, generated loads of, or attempted to generate lots of Bitcoin on behalf of somebody else, and ran them up a $110,000 bill within the space of a month. Now, Microsoft actually let them off a big chunk of that, but they were still liable for a huge chunk of cash. And it didn't do them any good from a financial perspective or from a reputation perspective. They were a solicitor's firm, a legal firm. So lift and shift goes beyond what you would expect in the case of, in case of issues, in case of organizations moving things into the public cloud. Okay, so another question can come in. In Azure, we are using Bash or PowerShell. We're going to use exclusively Bash. We're not going to use any PowerShell in this at all. So it's all Bash on the CLI. Okay, so enough of talking on that side. Let's actually get down to building and deploying out this infrastructure. So the first thing we're going to do is going to deploy our infrastructure code. We're going to provide you the code for this. You can utilize Terraform in the CLI shell or in the Cloud Shell to do this, and it's going to roll out everything for you. Then I'm going to give you a URL that allows you to attack your own web server, which is going to generate some traffic, generate some logs, and you're going to then try to identify the IP address of the attacks. Next thing is going to add some monitoring and some diagnostics. We're going to configure Cloud Defender. We're going to change the configurations on the servers to harden things, and then we're going to test it, review it, and go back again, and then re-attack the websites. That way we can then see what the difference is from a visibility perspective and some of the pitfalls you're going to come across when you utilize things like monitoring and logging services inside Azure. The cloud platforms are great. The cloud platforms are really good because they are technically capable of running all sorts of different systems and services in ways that you don't have access to on-prem. Unfortunately, they don't always provide you the most consistent approach to the data, or even produce the data in a consistent way when you then start logging or looking at the code, or looking at the data. So there are some pitfalls associated with this. Got another question come up in here. Once choosing the Bash, it's now asking you have no storage mounted. Yeah, just click OK and accept. It will create you a storage account. It'll do everything for you. And at the end of the event, at the end of the lab and the environment, there's some destroy code as well. It will get rid of everything. So we'll tidy up. Okay, so we are going to deploy our infrastructure. Now, in order to do this, you need access to, as I mentioned, you need access to an Azure account. So I've got an Azure account here. I've got a load of other things running in it as well, because this is one of my test environments for our NetWars services. But I'm going to deploy our SANS workshop data into here. Now, there's a few ways I can do this. Number one, I can actually use the on-screen version, which will request me a Cloud Shell after asking me to create a storage account, and this will give me access to a shell. This is great because it means I've got now control over the entire Azure account and environment from a command prompt embedded in a browser window. This is awesome. Also, incredibly useful if you're working on a corporate laptop that blocks SSH. It means you can still access this. But it's half a screen and it's a little bit annoying. So there is another way to gain access to that as well. This is a nice little trick. in the URL at the top, you can try shell.azure.com, hit enter, and that will then open up a full page shell. Oh, you're not getting any audio. Yes, you should definitely be having audio. I check your settings. There's only one. There's only you so far as mentioned that. But yes, if anybody else is having audio problems, you should definitely be able to hear me. Okay. Storage. You get this notification when you open up a shell that there might be an issue with storage, or there might not be any storage attached to your account. This is fine. Just accept the defaults, click next, and you should get to this prompt. Now we again have access to the shell. There is another way, and this is my much preferred method. We can open up a terminal window. Now this is Windows 11. You can open up a terminal window, and in terminal window, you can actually open up an Azure Cloud Shell version. And I'm going to click onto this one. I'm going to join back up to my tenant. Now, in this case, what would happen is this will give you an AZ login prompt. This will give you a code to log in, and I'm going to do this anyway because I want to demonstrate this capability. Okay, so this is now giving me another shell or another way in to the Cloud Shell. And I have, again, control over AWS, or sorry, AWS, Azure. Right. What I want to do, though, is I want to make sure I'm actually logged in as my user, and I want to make sure that when I execute the Terraform code that we're going to run, that it's going to execute properly and correctly. So I am going to run the command AZ login. Now, this you will have probably had to do the first time you log into this Azure terminal anyway. But I'm going to do it because I want to make sure that I'm actually logged in under the right shell. So I run the command AZ login. AZ login, I'll just full screen this for you as well, make it a little bit easier to see. AZ login starts a script that gives me a device login URL and a code to authenticate. Now I've got to make a copy of these and paste them into the browser, but I can't use Control-C to do it because Control-C in a shell kills this. Yeah, I can't do this. If you're on a Mac and you have a Kali Linux virtual machine, can I access the PowerShell on Linux? No, you can't. What you can do is install the Azure CLI tools on your Mac. And there is a document for that, but it's a bit of a process. I recommend you just use the web shell for this particular session. In Azure, Bash or PowerShell option, it's always going to be Bash. Always going to be Bash in this case. So I get a copy of this URL, paste it into the browser. I go back to the shell, make a copy of the code. Again, using right-click, not Control-C. Click next, and that will then authenticate me or ask me to authenticate to a particular account. Click OK on that account, and I'm away. I'm still in. So app get why PowerShell, yes, installs PowerShell on your SIM, but unfortunately it doesn't install the AZ CLI tools. They are different. Okay, so if I jump back to my shell, I can see that I am now logged in. And if I come in here, I can do AZ account list, and it shows me that I am logged in as my NetWars account, and I have then full access to this Azure subscription. I can now drop in and jump into my code. Okay, in the workbook, there is a reference to the commands you need to run. So git clone run or git clone https github.com cybersans /workshop _1 deploy. So this gives you access to my Git and will download the content that you need in order to build out this infrastructure. Now I've already got this, so I'm just going to navigate into the actual directory. Once you've run that git command and then you run ls-al, for example, it will show you all of the code minus there'll be a log file. You won't have that one just yet. But this is all of the code that deploys out the infrastructure that we're going to run. So need to deploy it. If you've never done anything with Terraform before, I'll give you a very brief introduction. Terraform is infrastructure as code. It's a way of writing out how you want the infrastructure to look, behave, and be built in code. And then you utilize the Terraform execution environments to build out that infrastructure in the Azure cloud. So if I look at the virtual machine, for example, called web server. So if I cat the web server TF file, I get a series of instructions here, which are Terraform instructions that it's going to build out this web server for me. It's going to grab some user data from a base64 encoded file. It's going to generate a random password out of 14 characters. It's going to create a network adapter, and it's then going to create a virtual machine with some standard configurations, including a disk, and it's going to base that on a Ubuntu 22.0 image. And it's also going to then output the password at the end so we can then log on to this machine. Now, that's just one example. There's a lot of Terraform code in there, but this is yours. It's yours to keep, yours to reuse, etc. So do have a good look at that one. So how do we actually execute this? Well, again, the instructions are in the workbook, but we run Terraform init. Terraform init basically performs some initialization tasks and make sure that your Terraform directory structure, as in the folder that we're in at the moment, is valid and there's no errors, no really glaring errors. The next instruction, though, is what's going to actually deploy out our code. So we run Terraform apply. Ooh. Now, this is going to read through our Terraform code. It's going to write out a plan in a temporary file, and then it's going to immutably create an infrastructure based upon that plan template. So it's going to deploy out our entire infrastructure in one set of code. It's going to roll out a web server, add on all the network connections, do all of the things that we need it to do. And it tells us what this plan is. It's going to create 295 items of all of these different things, all derived from that Terraform code. And it wants us to just accept that and say yes. And that now goes off and starts deploying this infrastructure. So in the next 5 minutes or so, I'm going to have a working version of this web server. And if you're following the process with me, then yeah, you are going to have that same as well. Could you please repeat the way you access the shell through the terminal? Absolutely. So in terminal, and it's Windows 11 terminal, unless you've manually added this to Windows 10, but in the Windows 11 terminal, if you click on the top little arrow bar, you get a Cloud Shell drop-down. From there, you can click that, will open up a Cloud Shell for you directly into the Azure CLI. Terraform init displays command not found. Make sure you are actually in the CLI. Does the Terraform apply usually take forever? Aha, welcome to the cloud. Yeah, sometimes it does. Sometimes it does, sometimes it doesn't. It really depends on how Azure's API is performing that day. Essentially, what Terraform is doing is it's interacting with the Azure API and delivering it instructions on how to build certain objects and services and systems. So yeah, it can take a little while to deploy. You can see on screen here right now, it's going through at the moment. It's creating as a group, and actually it's completed. It's added 295 resources. It's completed and finished. Quite interesting. Some may take longer than others. We are not all necessarily using the same API. Also, I am based in the United Kingdom, hence the reason why my accent. Yeah, so I might be using a completely different portion of the Azure API to you. Mine might be running quickly today. Yours may not. Terraform init displays command not found. Make sure you are actually logged in to the AZ CLI. So if you want to make sure you're actually logged in, you can run AZ account list. If you are actually logged into Azure and you are logged in under an account, if you run that command, it will tell you you are in Azure Cloud. If you're in the cloud name, it'll give you a tenant ID, a subscription, etc., and your username that you're logged in as. So that's a sanity check. Make sure you're actually logged in. What was the command that was run? So the command that was run is in the documentation. So it's in the SANS workbook. So in here, we use the git clone command to grab the data. We drop into the directory called workshop1_deploy. And then we run Terraform init and Terraform apply -- auto -- approve if you don't want to manually if you don't want to manually sort of type all of that in. I had to run the AZ account first, which before Terraform init, which worked for me. Great, okay. But you're getting a Terraform command does not exist. It's very strange. If you start writing Terra, and then just hit the tab key, it should autocomplete for you. Well, that's an interesting one. Okay. Anyway, my application, Terraform is case sensitive. Use all in lowercase. All in lowercase. Okay, so my deployment is complete. If I go back to my resource groups in my browser, I see I've got now a resource group called Sans Workshop, and in Sans Workshop, I have a web server virtual machine. It has a public IP address attached to it. So if I take a copy of that public IP, drop it into a browser, hit enter, yay, I've got my web application up. So we've started the entire process. Now, because my web application is up and everything is working, I can also navigate to our attack server. Now, our attack server, which we've provided for you. Oh, yeah, watch out for the CD again. It's CD space workshop deploy, or yeah, just watch out for that one. I'll update the documentation to ensure the case sensitivity. Yeah, absolutely. So I've got my IP address from my web server, not running in HTTPS, by the way. I've avoided that to reduce the complexity of the lab and the workshop. But I'm going to take the URL, the actual IP address. I'm going to drop it into my attack server. Now, my attack server is at HTTPS attack.cy63r.ninja. I'm going to put that in the Slack channel as well. This is the automated attack website you're going to use in order to test all of the functions and all of the security on your web application. So I paste my IP address in, hit go, and it says website found, search service not ready, run the final.sh script. This is great. What you might find is if you've just built your web service, the actual web application's not been provisioned yet because it takes a little while to do. You might find that it says website not found. Please wait. Just give it a few extra minutes and it will come alive. Retest it, you'll get website found, but the search service not ready. You've got to run the .final.sh script in order to make that work. So take a copy of that as a script. In the workshop deploy, if I just run the ELS channel again, you can see there are 3 scripts in here: the final, destroy, and app gateway fix. We're going to run the final script. Now, in order to execute a script in Bash, we do a ./final.sh. That will then run the commands necessary to fix and to finalize the deployment of the web application. Now, why are we doing this? Well, there's a couple of little things in there that allow you to, or that fix some of the API services inside the web application. You've been stuck on the Terraform auto approved for a while. Is this normal? It can be. Yeah, don't worry about that. Just give it a few minutes and wait for it to run through. When you run this final SH as well, it does take a little few minutes or so in order to execute this, because what it's doing is it's utilizing some AZ run commands, which allow you to execute code or execute instructions on the web server virtual machine, utilizing the Azure shell as root. So basically what it's doing is it's executing code as root on the virtual machine, on the web server, and changing some of the IP addresses in order to make the search service work and to stop the cause service from becoming a problem when we start downloading some files. Again, this is included in all of the code, so you can keep these and reuse them as you wish. Okay, so we wait for that to execute and run as well. Now, our Fairline travel application, well, this little application is very basic. It's got a search function that's looking for a serial number in order to get the flight coupons that you've booked through Fairline. In a moment, once those scripts are finished running, I'm going to demonstrate the actual capability on this, and we'll see exactly what this web application does. Right. Which command are you having issues with? Terraform init. Terraform has 2 R's in. So the commands you want to run are Terraform init. Let's see, here we go. Make sure there. Terraform apply. Approve. Those are your 2 instructions to build. Once you've finished that building and that deploying, make sure that website's actually working. Make sure the services is there. Go and test it through the SANS Workshop attack service. Make sure you get this search service not ready. Run the final script. In order to run that final script, just run the final.sh. Error acquiring state lock. Resources temporarily unavailable. Ooh, that's an interesting one. That probably means that Terraform init hasn't executed properly. I will change the documentation. Microsoft Word likes to auto-fix things for me, which is quite annoying. It also likes to correct my my spellings of things as well, such as defense and organization. I'm sure they've got S's in and not Z's, but there we go. Okay. So once we've got the application actually running, if I go back to my application here, click back on there, click process again. Now it's changed. So the site's found, the search request has been sent, and I've got a response code of 200. So that's actually run an attack against my web application. But what's it actually done? Well, your web application's got some interesting data attached into the back of it. If I navigate via Azure's console and go to the storage account, click on the containers, I'll just make this a little bit bigger for you. There's a folder in the containers called coupons, and in folder container called coupons, there are some flight coupons. And these are all files that are stored as part of the file structure in the back of the application. So if I take a copy of one of the serial numbers from there, go back and navigate this through my website, the idea is you click search, it finds, oh, it didn't find. It finds the file and then allows you to download that file. Okay, Terraform apply auto approve. Nothing happened, or how do you pivot to see the interface? Okay, so I think the issue you've got there is if the Terraform auto approve has applied and has finished, you will end up with results that look like this. So it will say apply complete, resources added, etc. If you navigate to your Azure account onto your resource groups, look for a resource group called SANS Workshop, and you should have these assets associated with that application. No, you don't. Okay, so what did Terraform auto approve do? Just a blinking cursor. Interesting. Okay. Blinking cursor just means that something's busy or something's not responded. You might want to just Control-C that command and then give it a few minutes in order to stop the Terraform execution before you continue. Work for you after a couple of tries. Brilliant. Okay. So So there's a serial number service inside this web application that allows you to search for serial numbers based upon the store objects inside the storage account. Now, this is a particularly vulnerable issue. This is, we've got a unsanitized field on a web application that's calling the services at the back end of the system to grab a file from an Azure storage account. Well, if we abuse that, and we abuse it utilizing this attack web server, it's going through a process of attacking that site and grabbing some files and stealing that data. There is no limitation on how many times we can search for those files. So theoretically, this site can be abused and would leak data incredibly fast. This is a bit of a problem. I was able to search using the numbers 1 and 2 exactly. Yeah, you know, it's like it's pretty weak, really. It's pretty terrible web application. That is the point. We need to be able to start defending this. In order to defend something, we have to have visibility. Visibility is the key element to this. So let's just jump back to our PowerPoint for the moment. So we now have this web application set up. It's laid out in a pretty basic way. We've got a web server, we've got a network security group that's providing some basic layer 3, layer 4 firewalling rules, TCP, so IP and protocol level. We've got a public IP address, and we've got an Azure storage account. That is very common in sort of a lift and shift scenario. So a few weeks ago, I was helping a friend of mine out. She owns a photography company. She moved her website to a new hosting provider, or got her web developer to do it. And then she contacted me and said, look, I'm a bit worried about this. I've just been told that I had 1,000 emails through on the contact form, and I haven't seen them, yet they apparently have been delivered, and I don't know if any of them are actually legitimate inquiries. So I did a bit of a dig for her and just had a quick look at her web application. And they moved her WordPress brochure website and they put it into GCP. Yet I could query it. I ran Zap scan against it. I did all the things I needed to do in order to verify what they, the changes that they'd made. And when I spoke to the web developers, I asked them, what visibility do you have over attacks against this website? And their basic answer was, we've got the logs from the web application, and that was it. And they had nothing else. And yet when I actually probed them and said, well, could you give me the logs for the web application? Because I want to check to make sure nothing else has gone wrong with this. They couldn't. They came back and said, oh, actually, we don't have access to that portion of the system. So they were using a third-party provider who was hosting in Google Cloud in order to be able to in order to be able to host this application. They had no visibility of what was happening at all. So they didn't know. This is a very, very common scenario. So how do we actually make this better? Right, okay, we've got, it took a second to get you a public IP address. Yes, you get a notification. The screen's running like mad and ending with this. Excellent. Yeah, 200 things started. Oh, you've got the blank IP address situation as well. Yeah, Terraform's a little bit in sort of, occasionally it does it, occasionally doesn't at the moment. You've got a public IP address as well, and it's added 295 resources. Perfect. So you should be somewhere close to being able to run the final.sh script that will finish off and build out and finalize your web application, and it will therefore go through the deployment process. Brilliant. Once you get to that step, you can then run the attack service against it. So we've built a web application. It's based upon code that we would have run off-prem, so it's just a standard virtual machine, really. We've built it inside Azure this time. We've positioned it so it's publicly facing the internet, and we've attacked it. Unfortunately, at this point in time, we have no logs. Literally, if I go to the SANS workshop, I click on my web server, and I click on logs. Oh, we've got no visibility at all. There is nothing turned on for logging on this virtual machine. Now, Microsoft like to suggest that, oh, actually, well, it's easy. You want to turn logging on, it's fine. You can go to Defender. You go to the Microsoft Defender for cloud services. You can go to the inventory. You can see the web server is here. Where is it? I've got a whole load of different services and stuff running here at the moment. But I've got the web server running there. There we go. And actually, that's not running the right one. It's running a different machine. But if I try and turn on the services, the monitoring services from here, what's actually going to happen is it's going to break. It's not going to work. And there is a slight flaw in the planning of this one. So if I go down to this virtual machine again, so I click on the web server and I navigate through on the left-hand side, I get this extensions and applications. This is where all of the logging agents get installed on this machine. I click on there, no extensions found. Great. I could add customized extensions for things like agent for monitoring Linux servers effectively. You know, and part of the Defender services means that you can just turn on these agents, turn on these extensions, and then gain logging data from there. But there is a bit of a problem. In fact, there's a major problem. The OMS agent for Linux. Now, OMS is the operations management suite. OMS is where we get things like log analytics from. So we've got a log analytics workspace. We've created one of those for you called Fairline Logs. And at the moment, Fairline Logs doesn't have anything in it. But we do have this notification. The log analytics agent, the OMS agent, used to collect logs from virtual machines was no longer supported from October the 31st, 2024. So that's in a year's time. But we have one major problem with this. We want to get logs from our web server. Now our web server, as we navigate through our SANS workshop and look at our web server service, our web server is running on a Linux Ubuntu 2204. 2204 is not supported by the current OMS for Linux agent because 2204 uses the more modern version of OpenSSH version 2. And that's a problem because it's not compatible. So if you try and deploy the OMS agent for Linux by going through Defender and attaching it via the inventory, what will happen is you'll end up with an extension attached to the virtual machine that can't execute. And it goes into a state called provisioned, which means it's broken, essentially. Or provisioning, sorry. It means it's broken. It means it's not going to work. And it's not going to capture any log data for us, which is very, very bad. Okay. So a couple of questions that we've got coming in. We've still got some resources being created. Missed the instruction on the blank IP is dealing with. Okay. If you want to get the IP address for your web server, navigate to your console, go into your resource group, click on the SANS resource group, click on the web server, and the public IP address is there. You can also check under the pip web server object as well. So again, you can go through the pip web server. I don't like doing this one because it actually gives you some extra information on the back of the IP address as well. So OMS agent for Linux already deployed on the web server VM? No, it's not. And if it is in a transitioning state, it means you potentially have a policy that is implementing and controlling that. You need to stop it and you need to kill it. Because actually, if you try and install that agent, it's going to block any other agent from being installed. And we need to put in the new MMA agent, which we're going to show you. I'm going to show you how to do in the next few steps. Okay. So yeah, watch out for that one. If it says it's in the transitioning state or if it says in its provisioning state, it means it's broken and it can't execute. You need to get rid of that agent and delete it from the VM. So how do we do this? Well, we're not got to that point just yet. What we need to do first is we need to attack our site, which we can use the attack web service for. And the next steps is we need to introduce some protection mechanisms for our actual web application. This is where we introduce the concept of application gateways. Application gateway is basically a fancy load balancer. Now, right down at the most basic end of the load balancers are what we call load balancers. In Azure, it's just called a load balancer. And a load balancer will balance traffic between objects that sit behind the load balancer, and it'll do it at layer 4. So we're doing it at IP and protocol level. So you've got communications coming on port 80. The load balancer will split those communications and will load balance between 2 web servers that are running on port 80. That's it, a simple concept of a load balancer. An application gateway is effectively a load balancer, but running at layer 7. Now, I'm going to introduce now the concept of layers inside the OSI networking stack. With 7 layers, the bottom layer being communications, the actual fiber, the light, the electrical signal going down a copper wire, or the radio if it's wireless. Layer 2, this is where we are dealing with the frames of the packets. This is where we deal with things like VLANing, okay, and ARP addresses, the address resolution protocol. So the MAC addresses of the actual network adapter. Layer 3 and layer 4, this is protocol and transport. This is where we handle communications, ports, IP addresses, protocols. Now, layer 5 and 6 is where we deal with session and transport, and layer 7 is where we deal at the application layer. This is the browser, and this is everything else that's happening. Now, an application gateway that's working at layer 7 basically means it can interfere and modify requests that are coming through for a web application. So we can introduce things like web application firewall technology into that firewall as well. So whereas a traditional old school kind of a load balancer that's only dealing with IP and protocol layer, well, it can filter or redirect traffic based upon IP address or based upon port. Layer 7 application gateways are load balancers that have the capability to filter traffic based upon the header of the request, whether or not it's a get or a post method for the HTTP service, whether or not it's hitting a particular URL or a domain name. We can also determine exactly which servers it hits, how many servers are available, and we can have an intense amount of monitoring to those services as well in order to be able to identify what kind of traffic, how much traffic we're getting through, and what we're going to expect when they do hit the web server. Okay. Oh, brilliant. You've got an error building account, could not acquire an access token to pass the running CLI. Now, this is a common error message. Thank you, Laura, for posting that one out. If you get this error message, if you look in the documentation that I provided, you're getting this in the workshop 1. Yeah, you get this error. There was an issue using the MSI. Now, the error varies depending on the account that you're using, but essentially all you need to do is run the command az login. Run the command az login, copy the device path URL from the script that it runs, paste it into your browser next to your authenticated Azure account, copy the code that it gives you as well, paste that into the next page as it requests it, click OK, click next, and wait. And it will authenticate you again, and then just rerun the Terraform init and Terraform apply command. And let me know how you get on. Okay, so our application gateway. Your web page is not reachable via the browser, but ping responds to the public IP. Great. So that means that your web server is still building. It's executing some instructions as part of the build process, and I'll go through those in a little bit more detail as we get towards the end of the session. So just give it a few minutes. It will come to life. So our application gateway, it's a way of filtering web application requests. And I don't just work for SANS. I am the CSO for a data center. I'm the security advisor for a number of companies, but one of my other roles is I'm the security architect for a social media app. The social media app is based in the cloud. It's all running in Azure, and we utilize application gateways extensively to protect that web application. But not just protect it. Actually, what we do as well is we filter off and create staging environments that sit parallel to the live platforms. And we use the application gateway to redirect the traffic depending on the original location of the request and the header of the request. So if we include in the header of request this particular special staging URL for that version, and we're coming from a particular IP address, the application gateway understands that and has rules, means it can redirect the traffic so that our developers can access the staging environments that they're testing, yet none of the rest of the public internet can access those staging sites. Even if you know the URL, you still cannot access those staging sites because the firewall and the capabilities of the WAF inside the application gateway mean we can redirect that traffic, but only if the source IP address is from the right location, or you are connected to one of our internal systems, for example, one of our VPNs. So it means we can run a staging environment that mimics, and it almost mimics perfectly, a live server, yet it's not accessible to anybody on the public internet. Only the live server is. Application gateways have a lot of these capabilities. Let's deploy. Okay, so how do we roll out an application gateway? Well, my recommendation would be, as we've deployed our infrastructure in Terraform, would be to utilize Terraform to write in application gateway instructions. But for the benefits of this course and this content, what I am going to do is I'm going to do a walkthrough effectively from this, utilizing the same instructions I've given you, and we're going to do this through the shell, through the console, rather than through the shell, or rather than through Terraform. Now, Terraform is an immutable application. What do I mean by immutable? Well, what I mean is, oh, it's running as well. Excellent. What I mean is by immutable is when you build something in Terraform, any changes you make to that infrastructure should also be built in Terraform. So you shouldn't go through a process of making manual changes because Terraform isn't aware of those changes that you've made. When you run Terraform apply again, it'll look at what's in the cloud, look at what's in your local TF state file, and compare the two. And if they don't match, it will try and delete whatever's in the cloud, or it'll tell you, no, it doesn't match, I don't know what it is, and then it fails. So if we build things in Terraform, we really should continue to build stuff in Terraform. We're going to deviate from that slightly for the purposes of this lab, because I want to make sure that everybody understands fully the steps involved in making up a application gateway and the controls that we're going to be putting in place. Now, if your deployment's not quite caught up with this, it's not a problem. This recording will be available to you after the webinar as well. Plus, you have the instructions, so you can go through those. And I will post an updated version with those capitalizations removed as well. So, how do we deploy this application gateway? Okay, first thing is we navigate into our SANS workshop resource group. Resource groups in Azure are just logical containers of objects. We're going to build everything inside the same container. I'm going to click create, and on the create one, we can then type in from the marketplace application gateway. We pick the first one. So it's an application gateway and it's a standard application gateway. Click create. This is then going to start asking us a series of questions about exactly what we want this application gateway to do. We pick our subscription and we pick the resource group that already exists, the SANS workshop one. We give this application, the gateway, a name. I'm going to call this one app gateway 1. I'm running everything in East US. I recommend, and your code will have executed everything else in East US as well, so I would leave that there. And I'm going to change the tier to stand to WAF v2. I want to include WAF rules in my environment. Now, I don't want to auto scale this. I only want one instance to run. This is a lab system. This is for testing purposes only. So I'm going to run one instance. If I was running this in production environment, I would set auto scaling turned on because this is a service that Microsoft offers, and there is a limit to the throughput that it can deal with. So from a capacity and availability wise, you would want to turn auto scaling on. This is a lab system. I don't need to do that. I also don't want this to run in an availability zone. Running in an availability zone means that we are running in 2 different locations, in 2 different data centers, on 2 different power supplies, and probably on different infrastructure platforms as well. That is by definition an availability zone, unless you're Google, in which case it might not be quite the same. They had a data center fire in London about 3 or 4 weeks ago, and it took out availability zone 1. And when they wrote the report afterwards, they said, oh, availability zone 1 was affected by fire. Availability zone 3 was affected by flooding at exactly the same time. And it makes you wonder, they put the fire out with water and flooded another availability zone. Well, the availability zone should probably be further away from each other than that, but it appears in that instance not going to be the case. I've not seen any of the documentation for it, so I can't say, but it seems a little bit strange. I would expect an availability zone to be in a different location. Next thing we're going to do is create a WAF policy. Now, there are some limitations on this WAF policy from this point of view of we are building out the application gateway first. This will set up a default CORS-based policy. There's a core rule set, a CRS rule set, derived from an OWASP and a Microsoft core rule set. So we just call this WAF, for example, and click OK. Next, we have to attach this to a virtual network. Now, I've created a virtual network for you called the SANS Workshop, and I've also created in the code an app gateway subnet for you to apply this to. Networking and subnets is quite a large subject. I'm not going to go into too much detail about it, but when you build an application gateway, it has to reside on its own subnet. The reason you're doing this is you're creating separations between services. So there's a logical separation on the networking side from the application gateway from your web servers themselves. You have to provision in enough space in your network to accommodate an application gateway. So when you're designing networks, beware that you don't want to set overcapacity on your network or set undercapacity. This is a really quite tricky element. Should I build the app gateway now or wait until it's attacked? I would attack it now because you want to see what it is that's doing. Step 4 is not prompting for a name or the same image. Ooh, step 4. Let's have a quick look at that one. Step 4 should just be click on the next for the front ends, unless you are looking at a slightly different prompt. If you could screenshot it for me, that'd be brilliant. Okay, so next we are going to click on the front ends. We've got to add in a front end to our web application. So the front ends, we need to add in a new public IP address. Now, we've got to be very specific with this because I have a script that runs and creates this for you. So we're going to create a new public IP address. We're going to call it app GW pip. App GW pip is going to be our new, it's going to be, there you go, there we go, app GW pip. It's going to be a new public IP address. So it gives us our web application a new IP address front end. So what's going to happen is the web application gateway is going to intercept the traffic that's targeted for the web server. And we can change and controls all of what can directly access the web server, and it means all of the web traffic coming in can be filtered by the application gateway. Here we go. Yeah, so front ends, click add new on the IP address, on the public IP address. How did I configure the virtual network? That's a really good question. How did I configure the virtual network? I did it in the code. So, oh, I've lost my cloud session. So I'll just have to create another one. Actually, I don't need to show you from that. I can show you the source code of the actual web application itself. Right, here we go. So in the main.tf is where all of the resource group is defined. It's also where the default VNet is defined and where each one of the subnets is also defined. So you can see I've got a gateway subnet, a standard subnet for the virtual machines, and then an app gateway subnet, which I defined in the code. There's also the public IP address for the web server is in that block as well. So all I did was I just structured the network configuration in the blocks of the code to make it a little bit easier for you. How much could this web application cost us in the scenario, roughly for a month? For a month, it will probably run at about $50–60. Over the period, if you push loads of traffic through it, the costs do go up. We have a application gateway that passes about 2 terabytes of traffic a month, and it costs us about $250, and we have it in an availability zone as well. So environment creation is still stuck at Azure virtual machine is still creating 19 minutes elapsed and increasing. Okay, yeah, I think you may have a little bit of a problem with that one. My recommendation would be to let it time out. It will die after about 29 minutes, 29–30 minutes, it will die. You can then run these 2 following commands. Oops. Terraform destroy. You can just run, wrong. There we go. Terraform destroy, Terraform apply. Terraform isn't perfect. It does have issues every now and again where it will it misses a response back from a web application, for example, and doesn't give you the information and doesn't give the Terraform execution back the correct information. Therefore, it sits and waits until it times out and dies. Welcome to Terraform. Remember, we are only deploying a single web server, some network, a public IP address, and a few other things. You get into deploying code where you're running out hundreds of machines at the same time, and you do get some interesting failures. Gateway hang-up. Backing out does not reset the pull down. Okay, let's have a quick look at the pull down area you've got there. Yes, so no, you need to click on the add new. You can't bind the public IP address of the web server to your application gateway. It's already bound to a network object. So you have to create a new IP address. So click on the add new, give it a name, @GWPip, exactly like in the documentation, and that will go through with you. Yeah, and then click OK. Exactly. Yeah, don't worry about the basic and the static and the standards and everything else. That's fine. That meets the same requirements as your application gateway. So it should look something a little bit like that. In fact, it should look exactly like that. @GWPip, written exactly that way. Next, we click on backend. Now, what we are doing is we're creating a load balancer. The load balancer is going to add in a filter at layer 7, and it's going to filter and allow all requests through the application gateway to objects that sit behind. So we have to create a pool of objects that sit behind. Now, theoretically, this isn't necessary in this instance because we only have one web server. But if you're running a production stack, you will have multiple web servers sitting in a scaling group that what we call a horizontal scaling group. A horizontal scaling group is where we build out multiple instances of the same server. So if we have a web server that's reaching its capacity for connections or for memory usage, or the application, the actual sort of IIS services inside are reaching their capacity limit, we can spin out another instance of the web server and another to deal with that capacity. That is the wonderful elastic capability of the public cloud. We are essentially just adding a single server into a pool in this case. So we create a backend pool called @GWBE pool. We select the virtual machine that we have that's only one available to us, which is 172.50.2.10. We click add. That has dropped us in our single target. So we have a pool that only contains a single machine. What happens if we did actually have multiple machines in here? Well, we could do it via a VMSS. What's a VMSS, I hear you ask? This is a virtual machine scale set. So a virtual machine is a single instance of a VM. We could create multiple instances of that VM, but actually there's a cloud platform service that does this automatically for us called VMSS. It's works in very much the same way, what it allows us to do is create instances of a virtual machine stored within inside a container. So if we wanted to add this as our pool, we select VMSS, and we'd actually select the VMSS object type, which will then add this rule in to that via that service. What this means is it means that scaling becomes a lot easier. It means we can add in very fine and granular threshold rules that allows us to scale out that VM. Okay, so we have my application gateway pool. The next thing we have to do is add in the configuration. We have the front end that is done. We have the back end with a pool. So we've got our IP address at the front, the pool of servers at the back. Now we need to add in the routing rules. And the routing rules are the bit that are really important, and often they're also the component that's really easy to get wrong. These are the rules that tell the application gateway how to manage the traffic and requests that are coming through. The interface for routing rule is slightly different. Have Microsoft changed something? Yes, they've added the custom error pages into the single page. Interesting. I'll have to see if mine actually does it. In fact, it does, yeah. They have updated the page. That's within 3 days. Yeah, welcome to the cloud. They do this a lot. Okay, so the first rule we're going to add is a HTTP rule. Now, this rule is going to listen. This rule is going to listen on a HTTP connection. There's going to use a public port on HTTP. It's only going to be basic, but we do need to set the backend target for this rule. So we pick out our backend pool, our application pool, and we pick out our backend settings. There are no settings. What are the settings? Well, the settings, this allows us to change the behavior of the communication that's coming through to the server. So the backend setting, again, is going to be HTTP. We are port 80. We're not going to do anything with cookies. We don't need to override anything else. So we can just add in that by default. Now we have a backend target. What we could do, and actually what is highly recommended, is we change it so that the listener listens on HTTPS and the web application listens on port 80. The application gateway does what we call TLS offloading, transport layer security offloading. We offload the TLS at the web application gateway level, and we communicate with the web application in the back end on HTTP only. But why would we do that? I'm going to open that out to the board. Why would we offload the encrypted communications at the application gateway and leave the communication open to intercept on the back end? Why would we do that? I'll leave that question open to you as we move on to the next section. We move on to the next few sections of this. So we've got a routing rule for HTTP. Now, our little web application actually has 2 web applications in there. The second web application is slightly different. Now, the second web application is an API. Now, the API is not running on the same port as the web application. The API is actually running, and the documentation is not up to date either. The documentation is wrong as well, so I'll have to update that one. It is a different port. Good question, Ron. So once I run the attack, how do I determine the attack information or the attacker or the IP address? That's it. It's a good question. There really is no way. You could manually parse the logs by logging onto the web server. That's really all there is. Exactly, Brian. Yes, the answer to the question. Yes. So why do we offload the TLS at the application gateway? Well, it's the border. It's the control element of the border that we've put in place. The communications from the application gateway to the web servers, that can be in the clear because we want to be able to inspect it. We want to be able to see what's happening inside those communications. So yeah, we don't want to encrypt it. Also, big change as well. We don't want to have the web servers handling all of the TLS communications. because it means we have to install things like certificates on them. It increases the load on the web application as well. Oh, it seems that you need to install the standard v2. Yes, you should be installing the WAF v2, not the standard v2 as well. Application Gateway SKU tier has been deprecated. Yeah, you need to use the v2 versions. Absolutely. So I need to update that little thing as well. Right, so we've got my backend settings. Need to add in another routing rule. The another routing rule is called API. The API priority has got to be number 2 because we've already got a priority number 1. We're going to call this listener API. It's public and it's listening on 8080, not port 3000 as the document says. So big marker on that one. Make sure you set the API listener to port 8080. Not sure how I missed that one on the documentation. But I will update that. Okay, so once we've done that, we have our public port listening on 8080 and we have our API. We click OK. It tells us that our backend targets aren't right. We need to change that. Yes, we do. We've got to add in our backend pool and we have to change our settings as well. Again, API port 8080, because that is our API listener port. Everything else can stay the same. Click apply and add. So we now have our HTTP port and our API port. Now, our HTTP is just the web server front end and the API is the service at the back end that actually performs the search service. Now we have those, we can click next. We could give it some tags if we want, some metadata, but we're going to click OK, create. Let it go through a validation, which it should pass, and then click create. That will initialize the deployment. Now, web application gateways can take quite a while to deploy. In fact, I'm going to give an estimation of around about 15 minutes for this to come through and deploy. Your backend target is different. Okay, that's, yeah. I'm not sure if you were supposed to share that one particular thing because that was not the right image. Okay. Okay, so we have our application gateway is now being deployed. We can see this on screen here. It's going to take a little while for that to actually roll out. The next thing we have to do is we actually have to add in a health probe. We can't do that just yet because the application gateway has to actually be functioning before we can turn on that health probe service. So the next thing we need to do is we need to turn on some logging for the web server. The backend targets is different. Yes, the backend targets. Yeah, absolutely. You should have. So look at the workshop PDF. Yeah, so the backend target, you need to click on the add new there. And then when you set up the HTTP, you set it on as port 80. But when you set up the API backend target, you use port 8080, not port 3000. That's the only difference. Just make sure you set that port to 8080, not 3000. So while that application gateway is creating, there are a few other things we need to do as well. We need to gain visibility to the web server. So I worked previously in a SOC. It's a VSOC. So it's a virtual SOC for other organizations. I was one of their principal consultants. I was also there to assist and make the lives of the analysts easier. The guy who owned that company, he was pretty specific about what he classified as good visibility. And he categorized it like this. There are 3 main elements of visibility. Logging, number 1, most important. We want to be able to log everything that's relevant to that particular web application. The next element to that is we don't listen to the salespeople when they say they're going to log everything, because I guarantee you the analysts don't want everything. They want what's relevant. So we have this balancing act to perform. We want to get the relevant, useful logs that are going to make the analysts' lives easier. And we want to get enough logs that the analysts are effective and efficient in what they're doing so that the customer's happy and they have good protection in place. But logs aren't everything. We actually want something else as well. The next thing on the list is network metadata. We want to see the communications metadata, who communicated with who, when, for how long, how much data was passed. This isn't the messages themselves, but the metadata about the messages. Why do we want this? Well, it collates really well against logging data. So if we've got logging data that's saying we're under an attack against our SSH service, we want the network metadata to collate and to collaborate that information. If we can see in the logs and the network metadata that there is SSH communications and password brute force attempts, we put the two together, we can see exactly what is happening. That gives us a great indication in two different mechanisms that an event has happened. The other benefit of network metadata in that sense is we have something else to identify indicators of attack and indicators of compromise against. So we can trigger alerts and alarms off that data in order to be able to then pass and look through the logging. And we get, again, gives us good indications of things that have gone wrong. The third element of this, PCAP. Yeah, actual packet capture, the forensic collection of data off the wire. Now, this is a problem in the cloud because it's not readily available. And when it is available, it's expensive. And it's also not particularly efficient in when you go to collecting it. In Azure, for example, there is no network tap capability. It became a part of a preview program, and then it was pulled a few months later. So it doesn't actually work. We do have what we call temporary packet capture based off network security groups. But again, it's not perfect. It's not ideal. We have to pay a premium if we want 10-minute response on that. We have to pay the standard version of it is where you get an hour response. Unfortunately, while it's packet capturing for an hour, we can't read the packet capture. So we go, okay, we're under attack. Turn on packet capture. Now we wait an hour before we can read the packet capture. It's less than ideal, much less than ideal. The limitation in the public cloud is we don't have access to layer 2. Layer 2, remember I talked about ARP addressing the frames. Well, packet capture works at the frame level. So packet capture is where we set network adapters into a particular little mode called TEP ring, and they sniff and become a passive interface and gather all of the network traffic off the wire. We don't have that capability in the public cloud. Why? Well, probably because there's a higher risk of gaining access to somebody else's data. And that's a risk that the cloud providers just will not take. So the technical limitations are we have limited capability to do this. We can build out dedicated machines in the public cloud, things like what they call AWS Nitro instances, or in Azure, we have services that allow us to turn on basic tap services based on network security groups, but we don't have full access to PCAP. That is the limitation of our visibility. Okay, so we've now set up a service for an application gateway. We've created an environment now where instead of just having a web server facing the public internet with its network adapter, what we've actually done is we've added in a application gateway. And our application gateway is going to filter on port 80 and port API for the API in port 3000. It's not, it's 8080. It's going to communicate through the application gateway, but we still want data. We've got to get information from the application gateway about what traffic is happening coming through this connection. We want information from the virtual machine. So in order to do that, we've got to turn on some monitoring. We also want to monitor maybe a data from the NSG for PCAP and for NetFlow. And we want some data from the storage account at the back end as well. Okay, so how do we do this? Hey, my application gateway is deployed. Bang on time. Okay, I'm not going to go to my application gateway though, just for the moment. What I am going to do first is, I am actually. I'm going to switch that around. What I am going to do is I'm going to turn on the application gateway services, the actual health probe. This is important. So if I navigate to my application gateway, the first thing I need to do in here is to turn on the diagnostic settings. I want it to send its data to my log analytics platform, which is part of OMS. Okay, so I have my app gateway 1. It's got app gateway logs, and it's going to send them off to Fairline logs. What I can do in here is I can set where I want that log data to route from. Now, yours may not have that in directly. Let's have a quick look. Just jump to resource groups, standards workshop. I just want to make sure it's not picked up some information from the previous install I've run. Navigate down to diagnostic settings, and there we go. Our app gateway logs are running into our Fairline log service. If I edit the settings, I can see that I've got that data being forwarded on, and it's logging everything: gateway access log, performance log, firewall log. Brilliant. The next thing I'm going to need to do with my application gateway is to modify one of the health probes. Now, this is an interesting one. As far as the web application is concerned at the moment, there is a potential issue with the web application, and that's because the application gateway doesn't fully understand how the API is working in the background. So I need to change this. So what do? Okay, we need to add in a health probe. Now, the health probe basically says, okay, what is this application gateway? What is the port number that it's expecting to communicate on? And what is the response we are likely to get back? So we create an object called API health. We set the protocol. We set the host. 127.0.0.1 is going to point at the web server. Pick the port from the back end. No, I want the port to be specifically port 8080. The path I want to be /API, because that's the path to my API service. And I want to pick the backend service API in order to thing it. And I want the particular matching conditions. I want to get a 404 back. And I want the response to be cannot get /API. Why do I want the response to be that? Well, the API works on post. If you send a GET request to it, so that we're talking about HTTP methods here, what we're doing now is we're saying we have, the document says use port 3000. I know the document should say port 8080. I'm not sure exactly how that version of the port ended up in this document, but I will fix that as soon as this lab is finished. I'll give an updated one. The next step is to so what we want the health probe to do is to monitor the API. Now, if the API is working and you send a GET request to it, it will actually return a 404 value and say cannot get. Well, that's good. It means that the API is actually working and the health check can test it. So if I click now test, I should get back a positive result. He says, crossing his hands and fingers. Should work. Yay, there we go. We get a tick. That means that the health test has passed. We can add that into the process, and we've modified our application gateway. So that's now going to save our application gateway with its health probe. It's going to monitor the path on port 8080 under HTTP rules. That means, why is the host lookup value a lookup address? The host value is a lookup address because it's basically sending the request to the default pool. So all it's doing is it's saying, well, look at 127.0.0.1, which is itself, but it itself is routing to the backend pool. So you're setting the route. If you set that address as an actual address, you would only be testing the health probe on a single virtual machine in your backend. Now, if you're in a backend school, it would a backend pool, and that machine was torn down, your health probe would fail, and your gateway would start producing 502 errors, as in everything's gone terribly wrong. Here's a 500 error. So this is why we put it to 127.0.0.1. What it's doing is it's testing its localhost rule, which is to return all internal requests back to the backend pool. Okay, now we've done that, we've got to run a final script on our machine. So again, I'm just going to jump back in here, go back to my Azure Cloud Shell. Because what we're doing now is we've changed the IP address that the web application is listening on. It's now going to listen on the web application, the application gateway IP address. So if we run cp cd workshop deploy and then run app gateway fix.sh. So again, little command line tool. This is going to update our web application code inside the web server. It's going to change the path for the API. It's going to change some CORS rules. It's just going to allow our web server to work. How did I navigate to the health rules? That is a good question. So go to your app gateway. It'll land you on the overview page. On the left-hand side, if you scroll down, you can click on health probes, and then you can click on add health probe, which takes you to the add page, or you can actually click on the one that I've just created, and you can see the settings there. Let me just copy that page and paste that into the here. You can see what the settings are. Okay, so that is our app gateway configured, set up, and logging. If I go back to here, this is now updating. Yeah, this is updating the IP addresses as well. And so if I now navigate to the IP address of the app gateway, I have my web application. So it's working through the application gateway. I also should be able to get a ticket value from there as well. Yeah, it's come back up. Ticket not found. There we go. One search. Yay! Download the ticket. It gives me a PDF version of a ticket. Brilliant. So our web application is still working. The API is working. Everything is working behind the scenes. We now have a protection in place for that application. So what I can do now is take that, go back to my attack script, my attack server, paste in the IP address, click attack. It's come back, it's found the site, the search request was sent, the response code was 200. So the attack has now worked again. If I want, I can also repeat that attack. So I'm going to just go back and go, yeah, attack it again, attack it again. That's going to be generating logs. It's going to be generating events now, and we can actually start passing through those events. But there is one thing we're missing. We haven't got the logs. We have communications now to our application gateway. We have logging from the gateway itself, but we don't have logging from the web server. And I mentioned that the Ubuntu agent part is the part that's causing us the problem. We don't have that issue. You need that last script? Yes, of course, it is. That one. It is the app gateway fix.sh. It's all stored within that workshop deploy for you. Okay, so how do we install and manage these agents? Well, we have to use the newer version of the agent, and the newer version of the agent relies on a different mechanism in order to gather data from that virtual machine. So rather than just going through the process of adding the OMS agent to Linux, which is the default mechanism for doing this, we can't do that because it's not supported any longer. We have to take a slightly different route to the end. So how do we do this? Well, we've got to create a data collection endpoint. That is the first element of this. So in the top address bar, if we look for a data collection endpoint, we have to create this endpoint, and we give it a few configuration settings. And basically, this is an entry point for logging data. We pick the subscription. We're quite fine with that one. We pick the resource group that we're using, and we pick the default region that we've built everything else in so far. We click next and create. Oh, what did I miss? Oh, I forgot to give it an endpoint name. So I'm going to give it a endpoint name, Linux syslog collector. That'll be helpful. Okay, click validate, click create, and then sit back and wait a few minutes. that will create us an endpoint. Now, my recommendation is when you create these for the first time, and you'll utilize these for lots of different servers as well. So once you've created these, they do cover lots of different services through the environment. Click refresh. There we go. We've got our Linux syslog collector. We are going to utilize this entry point to specify that in our data collection rules. So if we search for data collection rules, in here we can create the actual rule that we're going to send to the data endpoint itself. So give this one and call it web server syslog. Pick the resource group name. We're on the SANS workshop. We're in East US. We're going to select the operating system Linux. And if we click on that drop down, we should have the Linux syslog collector that we've just created. Now, occasionally there's the API doesn't always render these selection boxes immediately. You might have to refresh the page in order to get that to turn up. So if it doesn't appear, don't panic. Just hit refresh on the page. Maybe even drop back out to home and then go back to the data collection rules page again in order to get that field to propagate. Without having that selection there, it doesn't work. So once you've selected that, we then are going to pick the resources that we're actually going to attach. So we click on add resources. We pick out our SANS workshop. We select the web server, apply. So we now have our web server itself. This is where we're going to collect our data from. The next thing we have to do is we have to specify the sources of data that we want to collect from it. So the data source in this case, well, I just want the syslog, and I want it to log debug on absolutely everything. What did I say 10 minutes ago? Don't log everything. Don't log all the things. Well, in this case, I do actually want it to log all the things because we don't have much time to get it to generate some data. So the more data I can get it to generate immediately means that we can actually start finding things. Where do we want that data to go? Well, we're going to utilize Azure's monitor logs, and we can drop it into the Fairline logs workspace because that's what's been created for us. That's where all of our logs are going for these systems. So we can add that in as our destination data source. So we have now set a rule based upon the resource, the web server, based upon the Linux syslog, sending it to Azure's log monitoring. We can click that and create. And click create. And again, we have to wait for that validation to come through and to say that that's been done. Okay, we've got a couple of error messages on that page. The body of the backend's HTTP response did not contain the value. Okay, so your HTTP response value check is failed. So look, body of that. Some of your health not. I'm sorry. Yeah, you don't want to save it until it's healthy. Shouldn't you be in the SANS workshop rather than the default directory? No, the default directory is the tenancy. There's a difference in there. How did I go from the data collection endpoint page to monitor? Okay, interesting. Right, just go back to that page again. So data sources, or the actual resources itself. In fact, what I'll do is I'll go back to here and I'll go data collection rule. So I've got this data collection rule here. What I'll do is I'll create a new one just so you can see it. So new rule. It's temporary. Put in the resource group, SANS work thing. Yeah, Linux, data collection, endpoint, Linux sys collector. Next, this is where we create the resource. So click on add resources. I click on the SANS workshop resource, put a tick in the web server, click apply. And then next we come to add the data source. Yeah, searching in the search bar is the way to go. Yeah, exactly. Yeah, we have the data source, Linux syslog, and we get to pick the environments from there. My apologies if I went through that a bit quick. Okay. There we go. Yay, you got your API health on. Brilliant. Excellent. Fantastic. Okay, so what have we actually done there? Well, we've created a data endpoint. We've created a system that is going to collect data based upon the data collection rules that we just applied to that machine instance. So if we navigate back to Sans workshop, we go to our web server, and then we navigate to our extensions and applications. We should, in a few moments, we go, agent monitor for Linux, the Azure monitor Linux agent. So what that process has done, creating a data endpoint creates an entry point for the log data. Creating the data collection rule actually sets the rules for that data collection and installs the agent on the web server for you. Now, if you had quite a long process just to dump the logs in Azure monitors, is there a shorter way than this? No, there isn't. I mean, a little bit facetious of me, to be honest. There is. You can program this. You can automate this in Terraform code. The reason I wanted to go through this process and demonstrate this particular process for you is this should be considerably easier. When we utilize the OMS agent for Linux from Defender, you literally just went through Defender, pick your virtual machines, tick the list, and correct install agent, and that was it. It was done. All the logging would come in. You would be able to view all of the logs in Defender, but it doesn't work. And actually, not only does it not work anymore with Ubuntu 22.04 and above, it actually breaks any available logging for that server. So if you installed that Defender agent and then came to install the Azure Monitor Linux agent, well, they actually conflict. They conflict because they have a dependency nightmare of things like Python 3 versions and pip modules and some PAM authentication services that conflict and damn it and prevent you from actually installing anything else. So if you try to install the OMS agent for Linux, it'll fail. You then go through the data collection process and set up a data collection rule, which in turn installs the AMA agent for Azure's monitor services. That will also fail because the other agent has broken it. So this is just one of the things that you find when you're deeply embedded in all sorts of things in Azure that you wouldn't expect to come across. This should be a much easier process, but it isn't. I would assume you should be pointing the logs in the data center container we created earlier, but what is it? Yes. So the data collector container that we created is the entry point for the services, where actually the log data is now here. So if we go to the web server machine and logs, we can actually query the log data from here. So for example, if I just put in here syslog in the last 24 hours, it normally takes around about 15 minutes. Oh, I've added it normally takes about 15 minutes to get your first logs in. So it's a lot faster than the OMS agent. And there we are. There are our user logs. So you can see that we've already started getting a massive amount of data in just from setting up those particular systems. So for example, I could do from here, I could go, okay, where facility does not equal user. Oh, facility wrong. There we go. So there again, all the logs that do not include the user logs. So we can parse out a ton of that data, but you can see how fast that information has made it into those logs. So now we've got now we've got the log data coming from the Windows machine, from the Linux server itself. We have syslog, which means that we can monitor things like SSH. We've got things like the application gateway log is also now transferring data through to there. We've got an automated system that can attack us and do all of those other things. So Next couple of things that we can do to harden this process and to harden these systems. This is where we start getting into, well, let's start restricting and turning down our networks. Let's start limiting access or resources from our application gateways. There are lots of things we can do to harden these particular services from. So we can jump back to our SANS workshop. We have a network security group in here. Our next network security group is called NSG1. We have web app inbound, allowing port 80 and 8080 from anywhere to that destination. Well, that rule can now be changed. We don't want the public access to that web application directly. We want all of the application traffic to go through the application gateway. So we come in here and we go, okay, if we had a front door, a front door is just another level of application gateway, but it's a global load balancer rather than a regional load balancer, which is the application gateway. So if we want to do this, we could do like front door backend, for example. But got a bit of an issue on this one. We have an application gateway, but application gateway isn't listed in our services tag. So where is it? We have a lot of different services available in here, but it's not the one that we would expect it to be. It is actually a slightly hidden one and a slightly obscure one. But it is in here. I'll just find it for you now. Right, whereabouts is it? Somehow you got straight from Terraform. How did you get straight from Terraform? Let's have a quick look at that one. Sure, policy for Linux, Persian enabled on the web server. Oh, from the, okay. You got that straight from Terraform? No, impossible. I didn't write it in. I didn't write it into Terraform. Really? You have no data collector module installed at all? Do you have, is this an existing Azure account? Does it have any production workloads in it? Has it got policies on there that automatically deploy configurations out depending on virtual machine circumstances, etc.? I'll just wait for the answer to come back for that one. Oh, we've got another coming in. No, okay. Fairly new subscription, no policies. Really interesting. I'm not entirely sure how that agent got installed on that. It can't talk to anything because you don't have a collector in place. So that doesn't really make any sense. Okay. Right, so I was looking at this one anyway, I got slightly distracted. So what you're actually looking for as a service tag is Gateway Manager. So Gateway Manager is the application gateway rule that you can put into the NSG. So the network security group for web app inbound, we changed the source, set it to service tag, set it to Gateway Manager, still allowing on port 80 and port 8080. We apply that rule. What that does then is prevent access directly to the web server from the public internet and forces all communications to go through the application gateway. We can test that. So NSGs, they take anything between 5 and 15 minutes to apply. So we'll we have to wait a few minutes in order for that to take effect before we can test it. But what we have to do is make sure that our new web server or the web server through the public IP address for the application gateway is still working, whereas the existing website on the original access will be denied. As I said, network security groups take a few minutes to deploy, and we'll come back to that one and review. So we've hardened the virtual machine with in the sense of we've turned on some logging capabilities, and we've protected it using rules in the network security group. We've turned on an application gateway to protect the web server from the internet, and we've set up some rules in there, including WAF rules, which were applied by default, which means that we can start filtering on things like the controls or the policy settings for the web application firewall. So we have some managed rule sets in here. We've got the OWASP 3.2 rules. This is the core the CRS rule set that I mentioned earlier. These are things like the default rule set for behaviors included in the OWASP top 10. We can also have the ability to set in custom rules. So if a custom rule could, for example, we could set in a rule that said only allow regex queries in regex, only allow queries that contain this many values. That way, searching for number 1 in the search field wouldn't produce any results because it wouldn't pass the WAF. So there's lots of different ways we can implement control in there as well. And on our overview of this actual application firewall, we've also got the ability to do things like log scrubbing and setting up the associated application gateway. So we can use a single WAF rule associated with multiple gateways. Page 16, after number 8, not clear how to navigate to web server. Let's have a quick look at that one. Yeah, go to resource. Okay, yeah, I understand. I'll note it as well, and I will update that so it's a little bit easier to navigate. Yeah, so if you ever want to navigate to the resource group, you can click on resource groups, click on the SANS workshop, or go to there. Also in the top, you can navigate via the virtual machines as well, which will just give you a list of the virtual machines available. I didn't do that because I've got hundreds running in here at the moment. Can I walk through the NSG again? I had to walk away. Of course, I will just reiterate what we sort of discussed on that one. So go to SANS workshop. In there, we have our network security group. And by default, the web app inbound rule was set to any IP address, pointing at the destination IP internal on port 8080. We don't want that rule in there because it's opening it up to the internet. We changed the source to service tag and the source service tag to gateway manager. Gateway manager is application gateway. It's just not clearly defined. We select that as application gateway. That means that only the application gateway can now communicate on port 80 and port 8080 to that particular service. Or you definitely do. It is in there. You don't have an NSG in there for some reason. I'm pretty sure you will do somewhere. It's in there, maybe hidden. Okay. So what does our logs actually look like? Well, and we are running up to our time on this one. So if we navigate to our log analytics workspaces and log onto our Fairline logs, which is the log analytics space I created for you earlier on as part of the code that deployed, just because they do take a little bit of time to actually get in place. Get rid of that error message there. And we want to actually search through and view the logs from our log analytics workspace. Now, what are the logs that we're looking for from our application gateway? Well, we start by just typing application gateway, but there's not in there. They are in Azure Diagnostics. This is where your logging data comes from for your app gateway. So if you want to be very specific about the app gateway itself, you use the category function. So where category equals application gateway access log, for example. and run in the last 24 hours. Yay, we have loads of logs. We have tons of log data for that particular resource. Now, if we look at the log data for this resource, we might see that we've got things like we've got the resource provider, Microsoft Network. So the log data has been generated by the Microsoft Network service for the application gateway log. We've got an IP address, the client IP 81.161.229.185. There's a HTTP status request for 400. We've got some client response times, and we might also have some other information in there as well. For example, the source port that was requested. With the application access log and the firewall access log, we can actually start drilling down and finding out where certain requests have come from and how many requests have come from different places. So, for example, I could also add in where we've got in, for example, in this one, where the resource provider is the Microsoft Network. So we could say where source resource provider. Is this the quickest way of doing this for you? Actually, no. Let's try that. So at the end of the document, I've given you some examples about how to analyze some of the data from this diagnostic log, where we can sort of drill down a little bit quicker into some of those details. So what I'll do is I'm just going to grab the first one out of there, copy and paste it into here, which is the Azure Diagnostics, where the resource type is the application gateway and the operation name is application gateway access. This is going to give you a list of all of the IP addresses and requests that are coming through in order to gain access to that website. We can bring this down and we can see that we've got a client IP address of 45.251. Go next one down. We've got 193.35.118. They're all coming back with HTTP status 400. So they're looking at pages that don't exist. Pages that don't exist generally incorporated into things like scanning. So what we can do is we can say, well, actually, what we want to do is we want to know what kind of HTTP statuses we're getting actual hits on. So we can say and HTTP HTTP status. And this fills in a lot of this for you as well, so you can quickly tab in between. We can say anything over. Well, we've got an HTTP 200. Actually, what we'll do is equal 200. Oh, my camera just dropped off. Can everyone still hear me? Yes. Oh, excellent. Right, brilliant. I just had a bit of a glitch out there. I thought my camera had gone off. Okay, so what we've got now is Azure Diagnostics, where the resource group is the application gateways, the operation name is access, and the HTTP status is 200. Good thing. And here we go. A lot less logs. So we can see that actually we've now drilled this down and we can see that we've got GET requests. We can see the routing rule that was applied. We can see the HTTP status, the bytes sent and received, the listener name, the pool name, etc. All of this information is what we were missing when that application was directly faced against the internet. We've also got other in here as well. So, for example, we can render this into a time chart, or we can even grab information about requests that be summarized in invalid URLs, for example. So I'll just run this one as one of our last ones before I open the floor up to other sort of questions and answers. There we go. So we're going to summarize the application gateway by this. We go and click on the chart, and we can see all of the different URLs that have been attempted to access just in the time that this has been up and online. I mean, this is what been up 2 hours tops. And this is all of the challenges, all of the queries against this web application. We can see, though, we've got a number of application requests against the API. We can start drilling down into those, and we can work out, if you go through the queries that I've given you in the documentation, you should be able to identify the IP address of the attack server without cheating and doing a reverse DNS lookup on it. Not that I just told you how to do it, but you should be able to, from the logs, be able to demonstrate and prove where the attack server is coming from. And you should also be able to pass through the log data as well, and identify whereabouts and what the kinds of requests were that were coming through from that attack service. That's really the end of our lab. There is a huge amount of things that we could extend this into. All sorts of things like hardening down the storage account as well. We didn't even talk about that. We can actually limit the storage account so it's only accessible from the web server. We can do that by implementing network controls on the actual storage account as well. We can do additional items like create network security group logging. So we can actually turn on in the NSG, and I'll just navigate away from that one. In the NSG, we can actually turn on packet capture services in order to be able to set up things like NSG flow logs. So we create a flow log to capture the metadata and the network PCAP data stored in JSON, though not in PCAP, but stored in order to be able to gather forensic information about communications and connections. All of these features, all of these controls are all included in Azure by default, but they're not turned on. And organizations miss this in big ways. This is probably about 10% of the work required in order to really harden and secure infrastructure in the cloud. But it's a really good starting point. It's a really good indication, and it's a good little lab and workshop in order to explore those capabilities. I'm going to open the floor up to some questions. If you want to fire them away at me, I'm going to be here for at least another sort of 20 minutes or so. We'll leave the session on running. The recordings will stop, but we will get to that. We'll get to that point. Just one last thing before I sign off and hand you over. I'm just going to open up a shell session again, and I'll just explain to you how to tear this down and get rid of it if you're finished. AWS is so much easier to set up secure instances, but this is very daunting and onerous. Good to know. Yeah, I mean, I would agree with you on that one. AWS is easier to set up for setting up secure instances and everything else. What they're not so good at is visibility. Actually getting some log data and getting it all into the same place in order to collate information is actually considerably harder. One of the reasons why I do tend to work and lean towards Azure more than AWS is because you collate data. It collates data and creates links between objects so much easier than Azure AWS does. I'm not seeing any logs at the end of the session. Is this normal? It can be. Unfortunately, you've hit across one of the issues with Azure and their diagnostics logs. They normally come in within about 15 minutes. I have been particularly lucky today. This has really worked from the demo point of view. This has worked really well from my side. I have instances where, for example, the logs have taken nearly an hour to come in. I've had instances where they've taken 24 hours to come in. If I ever come across those instances, I generally tear down whatever object and asset I'm trying to log and rebuild it, because something has clearly gone wrong in the call to the API that allows that particular function to work. So yeah, unfortunately, if you do come across this kind of thing, if you are prepared to leave this environment up and running, then you will probably find your logs come in within sort of the next couple of hours. Is there an argument for using Application Gateway alongside Cloudflare's WAF? I wouldn't use a WAF again. I wouldn't use a WAF with a WAF. If you're going to utilize Cloudflare, and it's an amazing service as well, by the way, I really do like it. Cloudflare is very clever because they have this ability to interrupt the request with their proxy service, and they put everything through their array IDs. If you're going to use Cloudflare's WAF, I would be wary on 2 fronts. Number one, their CORS rule set, their CRS rule set, has some very specific things in for Cloudflare. And I've seen that break web applications. So put it into testing mode, test it, set it to detect only, Do all those things first, that's fine. If you are going to do that, I would still use an application gateway, but just don't use the WAF. Don't use the WAF version of it. Use the standard V2 version of the application gateway. Remember, the application gateway isn't just a WAF service. It's a service you can attach a WAF to, but really it's a load balancer and a TLS offload and a layer 7 filter. It's not the same. If Terraform, is there an argument for using the application WAF? Yeah, I hope that answers that question for you. Can these setups be made as presets? So once you have a safe and functioning instance, you can clone or have a default. Yeah, absolutely. This is what Terraform's for. Like, I've got Terraform code that will build an application gateway and a VMSS, the virtual machine scale sets, and all the network functions and the TLS offloading and all the layer 7 filtering and the diagnostic settings all in one code. So yes, you do it programmatically. That way you get to repeat it, you get to and you don't get any different instances. I have a statement that I always make whenever I'm teaching. If I write out instructions to build a web server and I give those instructions to 10 different engineers, how many different web servers do I arrive at? How many different web servers do I get? The answer is normally 11. It's crude. Yeah, 11, exactly 11. Have you been in my class before? Okay, yeah, it's 11. People learn in different ways. People have different techniques. If you give a set of instructions to an engineer, they will look at it and go, oh, well, I do that bit a little bit differently because I think it works better. And they will then build you a slightly different web server. The reason we use Terraform is because infrastructure as code means we have consistency in our deployments. Why do we use Terraform? Terraform works across platforms. Works in AWS, in GCP, in Azure, even works on VMware and for on-prem services. It's amazingly powerful. The documentation is incredibly good as well. But what you've got to remember is, and it's not entirely Terraform's fault, Terraform is integrating and communicating with the cloud APIs. Okay, and the cloud API changes. They don't stay the same all the time. You saw the snapshot in one of the documents in the document I provided was taken 3-4 days ago, and it's already out of date. The cloud platforms change things on a really regular basis. So nothing stays the same, nothing stays at the same version. Things update all the time. Terraform are playing catch up constantly. It's a game of cat and mouse. They're trying to keep up with the API. If you want a really reliable infrastructure as code capability, CloudFormation. Yeah, CloudFormation is almost perfect. All right, it will work. It will build any asset inside AWS. It will do it really reliably. But if you need to run anything in Azure, CloudFormation doesn't work because it doesn't support it. It's internal only. I would like to restart from the beginning. How do I destroy the Terraform and start over again on my own, aka clean slate? You can do this by running this command. You run from the CD workshop directory. So workshop deploy, just run destroy.sh. Hit enter, wait about 10 minutes. Nothing will exist. It will all be gone. That will delete everything and take you all the way back to scratch. Okay, so that's how you destroy the entire workshop infrastructure. Just run that one command, and that will get rid of everything. This Git and all of the associated documentation will be online for at least another 6 months. As I mentioned, feel free to download copies of the code. You can use it as you wish as well. The attack server will be online again for another 6 months or so feel free to use that. The attack server does have monitoring turned on. So if you try to use the attack server to attack anything else, it will ban your IP address, and really quickly. It does do a validation check. So if you're trying to attack a web server that's not the web server that we build as part of the environment, it won't work. It will just tell you the website doesn't exist. So but it does protect itself as well. So if you try and attack something else with it, it will block your IP address from requesting. The Git, as I said, will be up for 6 months or so. The documentation I will update. I will change that incorrect port number, and I will also update a couple of the slide images to match the latest version. Will the command also destroy the application gateway NSG we created? No, they will destroy everything. Yeah, the destroy command deletes the entire resource group. So it just deletes absolutely everything. Yes, there is a recording of the session.
Simon, I'll jump in here. There will be a recording of the session. It will be available through your SANS portal account under My Webcasts. And you would also be able to download Simon's slide deck, and that will be available typically in about 48 hours. In your SANS portal, you'll also be able to access your CPE credit certificate. Simon, thank you so much for your time, your expertise, for engaging with our community. Clearly, folks have learned a lot. Definitely, everyone should come to our next cloud workshop on September 6th with Ryan Nicholson. And Simon, do you have any other final thoughts to share?
No, just, feel free to play with that code. You can reach me on things like LinkedIn and Twitter. You can find all of those information from my SANS profile on the SANS website. Hope to see you at some point in person in a class. And if you do have any issues with this lab, do let me know. I will update it fairly frequently. And thank you for listening.
Thank you all so much, and have a wonderful rest of your day.